my sweet, sweet recording. So the plan for today is what I'd really like to do is try and get through all of this. So we'll start by going through empty predicates. We talked a little bit about it, I think, maybe. But I want to kind of go back over it because it's a useful idea. And then I want to talk about multiple quantifiers and relational predicates. Again, we talked about this some in the tutorial and things, but it doesn't hurt to go back over it. And then what we're going to do for most of the time today is talk about a very special predicate that we have in first order logic, which is identity. And we're going to talk about it in the first half of the course. So basically for the next couple of weeks, we're going to talk about just the kind of formal aspects of identity. In the second half, we'll come back and think about some of the philosophical upshots of identity. Because as I sort of said, really the rest of what we're going to do has to do with either the formal aspects of first order logic or the philosophical upshots of it. Thinking that maybe FOL or something like it is a good way for us to approach carving up the world. And identity is one of those things that makes things very weird. It seems really natural, but it actually leads to some funny things. So we'll talk about identity as a basic predicate, and then some uses we can make of it. Then we'll talk about definite descriptions, and I expect that'll probably take us through the whole thing, but if we have time at the end, come on in. If we have time at the end, we'll talk about finally formalizing the definition of a first order logic sentence. So that's the plan. Ooh, and I forgot. Do we want to go for break, or do we want to end early? Break is fine with me. Cool. So, yeah, around 9:30-ish, give or take, and then we'll pause and go from there. You know the drill by now. Okay. So that's the plan. Again, if we can get through all of it, awesome. If not, it's no big deal. We can just roll this into next week. Next week has some built-in buffer. Very cool. So the first thing is to come back to something I think we talked about last week, which has to do with empty predicates. So I said when we're talking about setting up our first order logic system, we've stipulated we can never have an empty domain. There's always at least one thing in the domain, one thing that we're talking about. And similarly, I said that names could never be empty. Names always pick out at least one thing in the domain, and in fact at most one thing in the domain. So we can have stuff that's there that doesn't have a name, but if we have a name, we know it's going to get us to something. What's interesting is predicates, right? These kinds of things, but we didn't say anything about them having to apply to things. And in fact, we can have predicates that, as it happens, don't apply to anything in our domain. A predicate that applies to nothing in our domain, we call empty. And empty predicates are actually really handy sometimes because they let us make things either false or true on the cheap. We'll give an example. Let's take our sample symbolization key here. So we've got our domain, people. We've got P is a Pokemon, and C is, I should say, is cute. I don't know why I put the extra A. Is acute. So using this key, how would we do all Pokemon are cute? Starting off with something nice. Yes. For everything, right? If we reach in and grab it and it's a P, then it must be a C. Okay. And how about some Pokemon are cute? Or some Pokemon is cute?
Yeah, I was also question about this in the notebook was exercise, and I wrote novel, but
Existential. Yeah. So here's something funny, right? We can have some, and it doesn't actually conflict with all. Right? So some people are mortal. True. But everyone's mortal. So sum just tells us there's at least one thing in the domain that satisfies whatever sentence, and that's compatible with everything in the domain satisfying the sentence too. But nice, that highlights, right? If you have some, and this is always the case, if you have some or you have there is, it's always, 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 always going to be the existential. So if we have some Pokemon are cute, it's our existential, and if it's the existential, what's going to be the associated connective? Yeah, the connective, the conjunction, right? So we've got existential X, PX, and CX, right? There's something in the domain that's a Pokemon and is cute. But now there's something funny about this setup. Given this symbolization key, what's interesting? What's about our, say, predicate P? Yeah? Yeah. No people are Pokemon, for better or for worse. So P here is an empty predicate. That is, given our setup, there's nothing in the domain that satisfies this predicate. That is, no matter what we pick in our domain, and we plug in here, it's guaranteed to not be a Pokemon. So this has a weird effect. And one weird effect is that no matter what we plug in here, for X, the P part's going to be false. But note, what's that going to do then for this sentence? If the PX is always false, what's the truth value of the bit inside the brackets? It's always true, right? Because a conditional with a false antecedent is always true. So we've just found a really cheap way to make these kinds of sentences true. If nothing satisfies the antecedent, they're always guaranteed to be true. In fact, 5 is true, 6 is false. And 6 is false because, well, look, it's got the conjunction, so we have to have both parts true. Yes?
But if my domain is people, so I'm talking about people. In 6, I also claim that that person is a Pokemon. So
Good.
Isn't that true?
That's what, no. So the problem is what we do is, this tells us there's something in our domain that we can plug in for the X that's going to make this true. That's what the sentence says. But of course, the sentence is lying to us.
Yeah.
There isn't anything in our domain that's a Pokemon or is cute. There'll be plenty of cute people. Right. But there's no one who's both a Pokemon and cute.
Yeah.
That's the thing. Again, it's helpful to think about what these two do, right? The quantifiers tell us no matter what you pick out for the universal, you can literally take everything, and it makes the sentence true. The existential says there's at least one. And then we're looking at what's in the brackets. Okay. So you have this, which I think is a very cool thing. When F is an empty predicate, that is, it's a predicate that nothing in the domain satisfies, every sentence of the form for all X, and then you have this as the antecedent, will be vacuously true. And it's vacuously true because there's basically nothing, right? It's empty. It's a vacuum. And the vacuum gives us truth on the cheap. This will be handy for us next week. Because next week what we're going to do is start coming up with what we'll call interpretations, ways to make our first order sentences true and false and things like this. So it's handy to remember. And in fact, this tells us something about predicates. When we're thinking about how they're satisfied by objects in the domain, predicates can be made true of everything in the domain, or nothing in the domain, if they're empty, or just some of the things. Is over, let's say, 1.8 meters tall. I'm guessing we have at least one person. If we took the domain of people in this room, that would be satisfied by some. Is over 2.5 meters tall, that's a predicate that's empty. And is over 0.5 meters tall, cool, we're all good. Again, you see the idea. So empty predicates are kind of helpful. There's another tool for us to use when we're thinking about how these things can be true or false. All right. On to multiple quantifiers. We talked about this in the tutorials, but I want to, again, go back over some of it. Most of what we've done has to do with one-place predicates. So like, is a footballer, or is American, or etc. But not all predicates are just going to have one gap. Some of them have two. So you might have loves, where you've got one gap that is the lover, and one gap that is the beloved. Or is adjacent to, where you have one gap that is the thing we're talking about, and then the second gap is the thing it's next to. And you can have 3 and 4, etc., etc., etc. For our purposes, we're never going to go past 2, but it's just helpful to note you could if you wanted to. Now what's nice is as soon as you start to have these multiple gap predicates, you can fill them in multiple ways. Again, we did this already, so I'm going to go quick. The gaps in the relation are different, and we can fill them in different ways. So we can have Finn loves Princess Bubblegum, right? Which, using this key, we have LFB. We have Finn loves Finn, which is LFF. Right? He has a healthy self-image. He loves himself. Finn loves Princess Bubblegum, but Bubblegum doesn't love Finn, right? LFB, conjunction, not LBF. And note, the order that we're writing them in tells us which spot they're taking. The one that's closest to the predicate takes the first spot, the next one along takes the second spot, and so on and so on and so on. And of course, right, in the English, we might have things like Princess Bubblegum is loved by Finn, but we can paraphrase that to Finn loves Princess Bubblegum, and we know exactly how to do that. Again, I think we did these last week, and we talked about these in the tutorials, so I'm going quick. But note, once we start having these multi-place predicates, well, we have multiple places, so we can do a bunch of cool stuff with them. One of the really silly but cool things we can do, when dealing with predicates, be careful about the order. One of the really silly things we can do is make sense of some apparent English ambiguities. So we might have everybody loves somebody. And you can read this as, for each person, there's someone they love. Or you can read this as, there's some particular person that everyone loves. And we symbolize these really close to each other, but they say different things. So here's our first one. For every x, there is some y such that x loves y. Contrast this with our bottom one, which is giving this sentence. And this says there's some x, something we can fill in for x, such that once we do that, you can pick anything you like, and it's guaranteed that that thing is going to love the object we picked for x. Now these come apart, and this is a particularly problematic example. I should probably change it, but we'll run with it, right? Our top one's true of a love triangle, right? Ron might love Hermione, but not love Harry. Meanwhile, Hermione might love Harry, but not Ron. And finally, Harry might love Ron, but not Hermione. So you basically have just 3 arrows. None of them overlap. A loves B loves C loves A. In that case, for every object, we're guaranteed to find something that they love. But note, it's not the same. No one loves the same person. Contrast that with our bottom one, where we have to have a kind of center of love. Ron has to love Harry, Hermione has to love Harry, and Harry has to love Harry because he's the Gary Stu of the story, right? Of course, he's not even really the actual heroine, but that's fine. So again, what we're really getting here is that once we have multiple quantifiers in play to go along with the multiple gap predicates, we can start expressing a whole bunch of cool stuff. As you might guess, this is kind of a tool we're going to use going forward. So, Here's a couple sample sentences. We've got a sample symbolization key. So we have little n for Nathan. We have big A for is an anime. We have F is a relational predicate, is a fan of. And R is a friend of. And our domain will be people and anime. The best things, really. And let's try and symbolize Nathan is an anime fan. How would we say Nathan is an anime fan? Well, we know part of it, right? So we know it's going to involve the is a fan of, and I'm going to go in the first gap, right? So it'll be little n, so it'll be F little n. But now we have a kind of funny thing, because what is it we need to do for the second spot?
You need to say that the verb designation is a sample something that is an anime.
Yeah, exactly, right? Or to kind of paraphrase the paraphrase, there's something that's an anime Nathan is a fan of. Okay, can we see it? Like Nathan is an anime fan. There's something that's an anime that Nathan is a fan of. And when we read it that way, we can just flat out do the symbolizing, right? It's going to be our existential X, AX, conjunction, FNX. There's something that's an anime, and Nathan is a fan of it. Again, do we see the kind of pull here? Yes.
But isn't the sentence with an figures? Because if they say Nathan is an anime fan, do I mean that he's a fan of all anime or some anime?
Good. So the nice thing is this captures that ambiguity. And actually the question earlier really helps, right? Because this allows for me to be a fan of the some, and it's also compatible with me being a fan of all. All this tells us is there's at least one, but it could be that every one of them would be one. That's the nice thing about that existential. Okay. With me so far for this first one? So how about someone is an anime fan? How would we do someone? Yeah? Yeah. But if we take the N away, right, we have to replace it. And what will we replace? Yeah. So what we want to do, you're almost there. So we want to have another existential, but we're going to have a new variable attached to that existential. So we'll have existential y, say, existential x, right? And then copy this, and instead of the n, we'll just plug in a y. And now what that's doing is letting us have a variable there. It could be anybody. Might be me, it could be somebody else. And note, what this is basically doing is letting us go from a particular name to start quantifying out, to generalize out. So we might do this. Again, just take our initial one and replace the n with a variable which we've existentially bound. So far, so good? And again, note, all we're doing here is we're just using the multiple spaces, and we're filling the spaces in different ways. Yeah?
Oh, then there's Nathan.
Yeah.
Sounds really vague.
It's weird because I'm the subject of the English sentence, and it feels like the variable x is the kind of subject of the thing. So I like the worry. Here's the neat thing. When we're moving from the natural language just to our formal one, we kind of drop the difference between a subject and a direct object. So in this case, when I say direct object, right, it's the thing I'm related to in our English sentence. So that just kind of goes away. From the purely formal level, we just have objects, and they're going to be related in some way. We don't have anything that has the kind of grammatical priority of being the subject of the sentence. If there is anything like that, it's going to be baked into our predicates. So you can kind of see it, actually. This is why it's important to have the ordered gaps. So there'll be the thing that is a fan, and then there is the thing that is the fanned to, right? That is the appreciator and the appreciated, much like with the lover and the beloved. So we don't keep the English grammatical point of emphasis, but what we track, hopefully, if we do it right, is the underlying logical form. This will only be true if this is true. And if there's any kind of point of emphasis about which one is the subject versus the object, well, that just falls by the wayside. Good. Yeah? No. So here's the reason. So, yeah.
Like if you want to talk about the names and animals, then maybe that this is some way you said and then
Yeah, if we wanted to. I mean, this would just involve a different symbolization key, right? So if, say, we just had a one-place predicate that was, is an anime fan, it'd be really easy. We just have F little n. So what this is kind of drawing out is exactly how we do the symbolizing will depend on what key we have, what predicates we want to have. Nice. Okay, yes? No, does not matter at all. In this case, there's no problem, there's no worries. And in fact, if you have two operators of the same type, so if it's two universals or two existentials, the order doesn't matter. It's only once you have the different ones that things matter. Okay, cool. And how about our last one? All of Nathan's friends are anime fans. Yes? Good. I love it, except for one thing. So this says, some of my friends are anime fans. But you got some. You got the sum perfectly. The trick here was, again, the quantifier. So, and that's true. Some of my friends are anime fans. But I want to see something stronger, right? I want to see that all of my friends like anime.
So I put the universal before the existential, right?
Yeah. We want the universal in the front, right? So what we're going to say, right, and we're so close, right, is we want to say, hey, for everything in the domain, if it's a friend of Nathan, well then what? Then there's going to be some object that's an anime that it is a fan of. No, we're literally just using what we have here, and we're going to plug it into the complex sentence we're generating. Again, you can paraphrase this. Everyone who's a friend of Nathan is a fan of an anime. That is, for Alex, if it's a friend of mine, then it's a fan of an anime. Well, hey, we know how to do that. And we just plug it in. We get this. And what does this tell us? This tells us for everything, if it's a friend of Nathan, then there is something that's an anime, and our original object X is a fan of it. Yes?
Yeah, I was confused about universal. There are so many people and
Yeah, good. So here's the important thing. If there's any animes that are my friends, which, I mean, but let's know too, right? It's got to be the kind of, it's got to take the first place. So it's not something that I am a friend of. It has to be a friend of me, right? It's got to be the kind of active participant in the friendship here, which I suspect is going to eliminate most anime. Yes?
Yeah, now is the existential inside the whole stuff. But can I also,
You can pull it out, that's
yeah,
perfectly fine.
so long as it's after the universe.
After the condition.
Yeah.
Yeah.
Okay.
Good. So again, we see the kind of steps here. It's nice. Basically, what we're doing, we start off with something just involving one quantifier, and then we replace that name with a new bound object. And hey, we can generalize. We can talk about some. We can talk about all. We can plug the same object in multiple relations. It's really lovely. System beautiful. It's ease of use. Just to stress, right, if I give you stuff like this, I will always also give it to you in an order like this, where there will be something like, hey, you've got some sentence, and then you can embed it into a later, more complex one. So that's something a little bit, you're welcome. All right. So let's start on talking about identity. We'll talk a little bit about how it works and what it looks like, and that'll probably take us up to the break, because we've got about 15-ish minutes or so before. So, identity is a very special predicate. It's special in both how we write it and what it is. So we write it with the equal sign. It's a two-place predicate. It's just like loves, or is a friend of, or is a fan of, or anything like that. Right? But we write it differently. So in every other predicate, what we do is we have the predicate first, and then we fill in gaps after. Identity, we write the names on either side. And notably, we never have to put this into our symbolization key. We know what identity is. We know what the equal sign expresses. It's baked into our formalism. It's not like any of the other predicates, where the letters could mean different things in different circumstances. The equal sign always is identity, always. We don't have to include it. So let me stress what I mean about the way we write. So if we wrote, let's say, to go back to an example we had before, Finn loves bubblegum, so write LFB. We said it's not the case that Finn loves bubblegum. We put the negation in front. For identity, you write the terms on either side. Notably, if we want to put a negation with this identity, you don't put it here or here as in attached to the terms. You put it in front of the whole predication. So the negation works just like it does with the top one, and it's applying to the whole identity claim. It doesn't apply to any particular part. So identity is strange. It's strange just already kind of syntactically. Now, here comes the philosophy. For the formal logic purposes, identity does not mean indistinguishability. That is, right, that all and only the same things are true of two objects when they're identical. This is a heavy philosophical issue. It's something we're going to talk about in the second half of the class as to whether identity and this co-substitution really are the same thing. But just from the purely formal perspective, whenever we say two things are identical, it means that what we really have is two names for the very same object. So, Superman is Clark Kent. Shock. We can express with little m and little c. And this just really tells us that these two names pick out the exact same object in the domain. Okay. So identity, special predicate, and it's useful. To be honest, it's one of the most amazing parts of our system. Because once we have it, we can express a lot of things that we couldn't do before. So here's an example. So we have our domain, be all people. We'll have two-place predicate hates, and we'll have little cb Scrooge. So how would we say Scrooge hates everyone? So how would we do Scrooge hates everyone with this key? Well, if it's everyone, right, which quantifier is it presumably going to be? Yeah. Sorry, I thought that was a hand. Right. If it's everyone, which quantifier is it going to be?
Universal X brackets C H C X.
Yeah, right? So we can paraphrase this as, for everything Scrooge hates that thing. For all x, HCX. Okay. Now notice, what's one consequence of this? What's one of the things that Scrooge has to hate? He's got to hate himself, which probably tracks with most of the story, but still, you know. How would we say Scrooge hates everyone else? Or Scrooge hates everyone other than Scrooge? Or Scrooge hates everyone except himself? 3 different ways to say the same thing. How would we symbolize these sentences? Well, we know it can't be this, right? Because this one entails that Scrooge hates himself. So how would we say Scrooge hates everyone else? Everyone who isn't him. Give you a clue. There's a reason we started leaving this off with identity, right?
Universal H bracket H C C identity H C.
So this tells us Scrooge isn't identical to himself. Close. We want to use our variable. So what we're going to say is, for all x, if x is not c, then HCX. Everyone who's not Scrooge is hated by Scrooge. For all x, if it's not identical to Scrooge, then Scrooge hates that one. Now, a couple things to say. When we have the negation, again, it always goes in front of the whole identity claim. So we won't say something like identity and then negation. We're sticking with our sentential construction rules about this, so it always has to be attached to something like a sentence, not just a chapter. Yeah.
The negation is connected to the whole identity.
Yes.
Could we have it before the bracket?
Yeah, that'd be fine. That'd be perfect. So the only reason maybe to have it just like this is to make it, if it was there, there's a possible ambiguity about the whole parentheses, or the whole conditional, but I don't think charity would reign there. So again, what does this tell us? For everything in the domain, if it's not the case that it stands in the identity relation to Scrooge, then Scrooge hates that thing. Nice. So identity is helpful for other instances or other sentences too. What if we wanted to say, no one besides Scrooge hates Bob Cratchit? Does everyone know who Bob Cratchit is? Well, he's Scrooge's little helper. Go watch the Muppet Christmas Carol. How have you not seen the Muppet Christmas Carol? Bob Cratchit is who Kermit plays in the film. Right? Yes. Right. So, no one besides Scrooge hates Bob Cratchit. How would we do that? How would we symbolize no one besides Scrooge hates Bob Cratchit? Well, we can help ourselves out a little bit, right? Let's paraphrase it. One way to paraphrase this is, everyone who hates Bob Cratchit is Scrooge. Does everyone see that? How that's just a paraphrase? Everyone who hates Bob Cratchit is Scrooge. So how could we then symbolize that? Well, it's again going to be our universal for all x. And if it's the universal, it's going to have the conditional. And our antecedent is going to be hates Bob Cratchit. And our consequence is going to be is identical to Scrooge. You might say it this way, but of course, there's also a lovely universal for all x. If it hates Bob Cratchit, then identical to Scrooge. Or another way to say this, it's not the case that there's something in our domain that's distinct from Scrooge and hates Bob. Same thing. I'm the same with only Scrooge hates Tiny Tim. Yes.
Isn't it the case with the existential sentence that I say, no one else hates Bob Cratchit, but I also want to say that Scrooge hates him, right?
Yeah. So interestingly, this sentence doesn't actually say that Scrooge hates Bob. It implies it, but it doesn't entail it. Because it could be true that no one else other than Scrooge hates Bob, and Scrooge doesn't hate him.
Yeah.
So then we can add that and cancel the implicature, which already shows that it wasn't entailed. It's not baked into the logic of the sentence alone that Scrooge hates Bob. That's why we can put it in the conditional too. Again, the same thing here. We can see this with only Scrooge hates Tiny Tim. This was the form I was just saying. Is that going to go with the universal? And note, these two are equivalent. At least the structure is. Obviously, the details are slightly different. But the basic structure here of the negated existential, the non-identity, versus the universal and then the identity. Interestingly, exactly as we were just saying, it doesn't entail that he hates Cratchit and or Tiny Tim. Okay. So again, identity is helpful if we want to say things like everyone other than or only. The real money from identity is going to be with what we can do next. Yes.
And then also the identity, so x equals c, and then put it in brackets and say equals something else and
No. So importantly, the equals is only ever going to take two terms, right? So it's just like loves. It has two gaps, and you can fill the gaps with names or with variables, but you can't start hanging it on to sentences or anything like that. That would be a different relation. And in fact, there's a really interesting and heavy philosophical question there about whether we can have these kinds of identity relations that take different kinds of objects. So whether we can have an identity relation between an object and something like a full sentence. Again, we'll talk a little bit about that later on. For our purposes, it's always between terms. Always between terms. Either two names or names and variables in some combination. Last thing before. Another very cool thing that we can do with identity is we can talk about at least, at most, and exactly. For example, let's just have our domain be universal, and let's have the predicate be is a beer. How would I say there's at least one beer?
the existential x dx.
Easy peasy. It tells us there's at least one thing in the domain that's a beer, thank God. Maybe a little early, but still. 5 o'clock something. How about there are at least two beers? Yeah. I mean, I think, so the natural inclination is we just have two existential quantifiers, right? Here's the problem. right? If we have this, right? So existential x, existential y, and x is a b and y is a b. Oh, so bxy, we can't do that, right? Because b isn't a two-place predicate. So b is a one-place predicate, it tells us is a beer. So we can only ever write it with just a one term after. So this would be the simplest way to say something along the lines of what we were after. But this isn't going to give us there's at least two. Why does this not give us at least two?
Make sure that x and y are not the same thing.
Yeah. So the problem is, as this is set, nothing prevents us from using the same thing for x and for y. To put it in metaphorical terms, as this is written, it allows for me to reach in, grab something for x, and say, cool, here's my beer, and then reach in and grab the very same thing for my y. Nothing prevents me from using the same thing twice. Let's put it another way. If we plug this same lonely beer in both for x and y, we make this sentence true even though there's still only one beer and that we're very unhappy because one isn't enough. So how could we say there's at least two? Well, we want to say that there's something that's a beer, and there's another thing that's a beer, and they're not the same. How would we do it?
By having, like, x equal identical not y.
Yes. So what we want to add is a third conjunct, or a second conjunct, to this bit, right? We want to say, hey, we've got something x, and it's a beer. We've got something y, and it's a beer. And it's not the case that they're identical. Again, what does this tell us? Now we have to reach in, grab something from the domain for our x, reach in and grab something for our y, and they have to be different things. So we figured out how to do at least one. We figured out how to do at least two. Yeah.
Can I also, probably not, but can I also say conditional instead of a conjunction?
So that would be too easy to make true. It's the same problem that we had before with like some kitten is cute, right?
Yeah.
So again, usually 80% of the time, if you have an existential, it's going to go with conjunction.
Yeah. Okay.
That still holds true. It's the same stuff, right?
Yeah.
The stuff I said before is still the case. Okay. So we've got at least two. How would we do at least three? Yeah. Basically, well, this is just getting started. Right? That's what happens between 6 and 6:30, and then. So how would we do this? Well, basically same principles, right? So we want to have an existential x, an existential y, and we'll finally get an existential z. Each one of them needs to be a beer. So bx and by and bz. And then what's the last thing we need to say? Well, we've got to make sure that they're all distinct, right? So we're going to have x's and y, and y isn't z, and x isn't z. Basically just adding some negated identity claims as conjuncts to make sure they're different. So again, what does this tell us? There's an x, a y, and a z. X is a beer, y is a beer, z is a beer. X and y are distinct. Oh yeah, and x is distinct from z, and y is distinct from z. So this forces us to have three different objects. Because if I had even one thing twice, then at least one of these conjuncts would be false. Because the identity claim would be true. Yes?
Don't you all also
then you could have the same one from Y and Z. I know, it feels like you should be able to save some time, right? But importantly, right, what we need to do is to make sure that by having all three, we guarantee that there's a different object for each one of our variables. Nice. Good question. Okay. So we've used identity to talk about only, as in only Scrooge hates. About everyone else. We use identity for at least. Why don't we take our break, and then we're going to come back and use identity to do at most. Why don't we take a break until 43, so 10 minutes?